now we're going to be working on distributive property. So we're staying in the same unit, 7.3.1. Don't forget to add your name and the date. This time we're going to be using properties, including the distributive property, to write equivalent expressions. So how can I use the distributive property to simplify expressions? You're probably wondering. Well, let me tell you. So this is a really fun example, the distributive property baby. So we have b parenthesis a plus y equals ba plus by. So if we have a value that is in front, using the distributive property, the value in front goes to everything inside the parentheses. So in this case, the b goes to the a, and the b goes to the y. But because these are separate, they stay separate. So that's why we have ab plus by. So here's a math example of using the distributive property. So we have 4 times 36. That's also like saying 4 times 30 plus 6. So that's just this written out. So 4 parenthesis 30, and then 4 times 6, because this 4 gets distributed to the 30, and this 4 also gets distributed to the 6. So coming over here, it's kind of the same thing. A parentheses b plus c is equal to ab plus ac. So as a math example, 2 times 3 plus 4. So the 2 distributes to the 3, so 2 times 3, this part, and then 2 times 4, this part. And then we just get to compute that. So 2 times 3 is 6, and 4 times 2 is 8. 6 plus 8 is 14. So let's practice that. So we have 6 times 13. So that's also like saying 6 times 10 plus 3. So now I can think about what that means to be distributed. So that means that I have 6 times 10, and I also have 6 times 3. So in other words, I have 6 times 10, which is 60, and then 6 plus 3, which is 18, and 60 plus 18 is going to give me 78. So let's practice again. So 4 times 19. So that's just like saying, so we have the 4, that's what we have in front, 4, and think about how this 19 can be broken apart. 10 plus what can get us 19? 10 plus 9. That's a 10. 10 plus 9 can get us to 19, right? So now like what we did on top, how we distribute out from the 1. So 4 times 10. And I like to draw those little loops because it helps me like visualize where it's distributing to. And then 4 times 9. So we're adding that 4 times 9 because of this plus symbol right there. So we have 4 times 10, which is 40. 4 times 9 is 36. So 40 plus 36 is 76. Alright, so I know there's a variable, but don't let it intimidate you. Since we have it broken apart already, all we have to do is think about what it can be like if we distribute it together. So that's going to look like this. If we think about the 5 and the x, that's just like saying 5 times x. And if we have 5 on the outside and the 3, that's just the same as saying 5 times 3. So it's just like what we did up here, but we're just adding a variable. So 5 times x is 5x. 5 times 3 is 15. That is how it distributes. So let's think about that over here. I'm going to give you guys a couple of minutes, pause the video, and we'll do these two, and then come back. Alright, welcome back. So, for this top one, don't forget that 2 times x gets to be 2x, and 2 times 4 is 8. So this is it. We just leave the variables as they are. So then for this one, we have 8 times 4 is 32, and 8 minus y, 8 times negative y. This should be minus, not adding. So remember when we have those signs, we can't forget about them. So 8 times negative y gets us to negative 8y. Okay, because that negative distributes through. So let's think about this next one. 2/3 times 9x plus 12. So good thing we just had a multiplying fractions unit. 2/3 times 9x. So when we're thinking about multiplying fractions, 2/3 times 9x. And then we're adding 2/3 times 12. And remember, when we have anything, when you have a whole number, we're just putting that all over 1. So think about this part together and then this part together, kind of like parentheses. So when we're just doing these, all we do is multiply across. So 2 times 9x is 18x divided by 3. So think about how that can be reduced. 18x divided by 3 can be reduced down to 6x. And then we have the 2 times 12, which is, I'm going to write that up here. 2 times 12, which is 24. 3 times 1 is 3. Remember, just multiplying across. 24 divided by 3 is 8. So this is what we are left with. 6x plus 8. So when you have fractions, you're just multiplying across like you do when you have regular fractions, even if there's a variable in there, right? Okay, so what can we do if we have multiple properties to write equivalent operations? Well, first you distribute, and then you simplify. So to start, we'll start with this one. So I see that there's a negative 3 right here, or it can be 3 as long as we keep subtracting. But I'm going to keep this as a negative 3. So we have negative 3x. So we have negative 3 times x, right? Because that's what happens when we distribute that. And then negative 3 times negative 6. So if we're adding negative 3 times negative 6y, because that y stays there. So let's compute these. So negative 3 times x is negative 3x. Negative 3 times negative 6 is a positive 18y. But we still have this 15x to deal with. So we're just going to bring that right down. So we're just going to write 15x minus, so we have 15x minus 3x plus 18y. So we can combine these because they are the same. 15x minus negative 3x. Remember, we're going to do keep, change. So keeping the 15, changing the sign, changing that number. So we have 18x plus 18y. Okay, so let's finish off the last one. 7x plus 3 minus 4x. So again, we're taking the 7, distributing it. So we have 7 times x. Now we're going to take the 7, distribute it to that 3. 7 times 3. But we're still keeping that piece. So I'm just going to rewrite that. Minus 4x. And I'm going to compute 7 times x, 7x. 7 times 3, 21. And we still have that minus 4x. So now I'm going to combine my like terms. So when I say that, I'm going to combine these two x's. So 7x minus 4x is going to get me 3x, and then we're going to keep that 21, plus 21.